right, so welcome back. Happy Monday. Today is class number 20. Project number 2 is due right here, right now. Put it in the green folder at this moment. So the policy in the syllabus, which I mentioned last week, is that the projects are not accepted late. So hopefully whatever you've got, you give it to me right now. Today is our second day on inverse functions. Next class is the review for test number 2, and our second test is coming up on Friday. Questions on anything in the calendar? Okay, so let's jump in here. So I think a bunch of us have worked through most or maybe all of this one preview exercise. But thinking about this question here, it says, is the inverse relation a function? What was the answer to that one there? Is the inverse relation a function? No. So remember the idea with inverse, one of the ideas is that what happens to the x and y is they swap, right? And so I'm just going to write these 2 points in the middle here. 1, -1 by swapping x and y. 1, 1, that one's hard to tell that they've been swapped, but they have. And looking at that, we can say that does not represent a function because there is a single input, 1, which has what? 2 outputs, -1 and +1, right? And we know that's not a function. So the answer here is a no, because of those 2 points right there, right? A single input has 2 outputs. If you have a function where the inverse, that's the stuff I started to write in orange, is also a function, then the original function is called 1-to-1. So the original function here is not 1-to-1. But if we did have a function here in orange, then the original function would be called 1-to-1, okay? Just means that for every x, there is a single y, and vice versa. It is 1-to-1. That's not what happened here. Okay, so coming down here to the demo, number 1 says, does every function have an inverse function, and how can we tell? To answer this question, we're going to examine these 2 functions, f of x equals x plus 1, and g of x equals x minus 1 squared. Second part here says, here are 4 possible solutions. I'm gonna change that. I'm just gonna say 4 points on the graph. Probably we know what we mean when we say solutions, but I like phrasing it that way instead. 4 points on the graph. For example, if out here, if x is equal to 1 and you plug it in, how much is f of 1? 2, right? Just 1 plus 1 is the 2. Okay, so we got 4 points that are on that graph. There are many more that are not listed up here. And you could take each of those 4 points and you could reverse the components, and that's what we've done in the next line. And then we look and we say, does this set of pairs in the next line represent a function? What do we think for that guy? It does, because we don't have the issue we had up above, a single input leading to 2 outputs. That's the problem. That's not a function. But here we don't have any repeats of the input, right? These are all 4 different x's. So we never have a single x with 2 different y's, 2 different outputs. So in this case, it sure looks like the inverse of our original is a function. Same idea here, but now with g of x equals x minus 1 squared. And so you could plug in -2 and 1 and 0 and 3. You could plug in a lot of numbers. And when we reverse those pairs, what do we notice? We have which 2 points are the problem ones? 4, -1, and 4, 3, right? And let's just think about, make sure we understand what the problem is here. When you plug 3 in for x, 3 minus 1 is 2, squared is 4. But if you plug, if you plug -1 in for x, -1 minus 1 is -2, squared is still 4. So we had 2 different things that got sent to 4, and when we reverse the components, we got 4 going to 2 different things. So we don't have a function in this case. Certain inputs produce the same output. That means the inverse of g is not a function. Okay, so hopefully there's a better way to answer the question, is the inverse a function or not, than by listing ordered pairs. Number 1, listing ordered pairs is tedious. Number 2, just because you list 4 ordered pairs and don't find any matches doesn't mean there aren't some matches out there undiscovered, right? So you can't just list ordered pairs and say, oh, I know this is going to be a function, because you can't list all of them. So let's think about this picture right here. Part A says, by the way, these are the 2 functions we were just playing with. So whoops, go away. F of x equals x plus 1, that's our line. And then our friend, this parabola that's been shifted a little bit, is there. And so the first step says to draw the horizontal line y equals 4. So let's draw that. 1, 2, 3, and I think 4 is there. So there's y equals 4. So next question, how many times does that horizontal line intersect the graph of f, which was the diagonal lines? How many times does a blue line intersect the diagonal line? Just the one time. Right there, right? And so that means, for example, that f of 3 is 4, right? F of 3 is 4. And there's no other f of something you can plug in and still get 4 as the answer. Agree? Because that's the only place where the diagonal line hits at y equals 4. But if we look at the parabola, so how many times does the line intersect the graph of g? How many times does the horizontal line intersect the graph of g? 2 times. Once there, and then once again over there. And so for this one, it was at -1. So how much is f of, g of -1? It's 4. That's that first point. You could verify it from the equation, but we don't need to. We're just looking at the picture. And the other guy, is the other guy at, what is the other guy at? Is it 3? 3. Wait a second here. There's some funny business. I mean, I feel like they should both be hitting at 3. 3 minus 1, that's 4. 3 plus 1 is 4. All right, I didn't. Maybe my line is, maybe my blue line is flawed. I actually think the blue line is supposed to hit there. I think all 3 of them intersected that one spot. Okay, so looking at this guy here, so on the parabola, what we see is that g of 3 is how much? It's 4. And that's the issue, right? I mean, it's no problem for the parabola. The parabola is a function. But if you think about the inverse of that parabola, whatever it looks like is not going to be a function. Because if you flip these coordinates, then on the one hand, 4 gets sent to 3, and on the other hand, 4 gets sent to -1. And so what can we think about for that parabola? What feature, what characteristic of this parabola makes it so that immediately we can say, oh, the inverse is not going to be a function? Yeah, we are going to talk about some reflection stuff, and that's kind of the issue here, is that the parabola has a line of symmetry, like a vertical line of symmetry. But what feature of that blue line that I drew there tells me that the parabola is not going to have an inverse that's a function? Liam. Parabola intersected at 2 points, right? We didn't care what the 2 points were, but as soon as the parabola gets intersected by that horizontal line at 2 points, its inverse is not going to be a function. And that's something that has a name. Here it is. If any horizontal line, such as the one we just drew, intersects a graph at 2 or more points, then the graph of the function will not have an inverse function. We refer to this visual test as the horizontal line test, or the HLT. There are going to be some of these in the activity, but I'll just draw 2 of them here. Okay, so the question is, for each of these 2 graphs that I've just drawn in blue, is the inverse a function? Is the inverse a function? So if we look at the first graph, and you draw, for example, a horizontal line. Let me extend this a little bit. Okay, so we'll draw a horizontal line here. How many times does that hit the graph? Just once. That's okay. How many times there? Just once. How many times there? 3 times. As soon as you find a horizontal line that hits more than once, the inverse is or is not a function. Is not a function. So this one is it's a no to a question that I haven't written, but the question is the inverse a function? No. As soon as you find a horizontal line that hits more than once, it's a no. Looking over here, how many times does that horizontal line hit? Once there, once there, once there, and the inverse in this case is or is not? Is a function. So that's the horizontal line test. It's a very easy test, but just make sure you're clear on what it is that you are testing. question is always, is the inverse a function? That's the question. Okay, number 4, last new idea for this class, and then you'll do some stuff in the activity. Okay, scrolling up just a bit. Let's see how to find the inverse of a function algebraically. So that is to say, we're going to take this formula right here, f of x equals 5x minus 6, and we're going to create a formula for the inverse of that function. Again, we're going to create a formula for the inverse of that function, the function which undoes 5x minus 6. Okay, so there's a process here. It says we can obtain the equation for f inverse by interchanging the role of x and y. That makes sense because that's exactly what an inverse does. It just swaps the x and y. And then we're going to solve the new equation for y. Your textbook refers to the procedure for finding functions inverse as the switch and solve strategy. So we're going to switch the letters and we're going to solve for the new y. So let's give it a shot. 5x minus 6. First step is to think about whether or not the function is 1-to-1. Does the function, is the inverse of this function also a function? That's the question. Well, just graphically, y equals 5x minus 6. It's just a line, right? Fairly steep line. Is there any horizontal line that hits more than once? For sure, no. So this guy is 1-to-1. So its inverse is a function. So we're moving on to step 2. Replace f of x with y. So all we're going to do is change the f of x to a y equals. All right, that's an easy step. The next step is to interchange x and y. So the new equation is what? X equals 5y minus 6. Okay, so you interchange x and y. Makes sense. That's what inverse does. And then step 4 says solve for y. So we're going to solve this new equation for y. So first we'll add the 6 to both sides. So x plus 6 equals 5, y. And then finally, how do we solve for y? Just divide everything by 5, right? So we get y equals x plus 6 over 5. This isn't written here as a separate step, but I would like to write it as a separate step. I'm going to rename this thing. You guys remember from our last class, and we saw it a little bit today, the symbol for f inverse. It's f, and then how do we symbolize it? Yeah, it looks like a power of -1. So that's what we're saying, is f inverse of x is x plus 6 over 5. That's the formula for the inverse, okay? Okay, and just as a quick check to make sure that we didn't make any silly errors, I'm just going to pick a number here. F of somebody make up an integer, 3. So just picking a number 3. How much is f of 3 up there? 5 times 3 minus 6 is 9. Everybody agree? Okay. What should we be checking to see if we have the right f inverse function there? F inverse of 9. That's what I want to check. Right? 3 went to 9. What am I really hoping happens with 9? Goes back to 3. Let's check. Down there. X plus 6 over 5. 9 plus 6 over 5. Yeah? 15 over 5. Which is 3. Does this prove that we found the inverse function? 3 went to 9 and 9 went right back to 3? I know. Mm-hmm. Mm-hmm. Other thoughts? This is evidence. So for sure we've got evidence here. 3 goes to 9 and 9 goes to 3. That's great. But what if we made a mistake over there, but it just happened that we got lucky here? 3 went to 9 and 9 went back to 3, but maybe if we had started with 4, it wouldn't have come back to 4. Isn't it possible that we made a mistake over there and we just got lucky here? So what if we try f of 4? What if f of 4 works? Does that mean we win? Is there enough points that we could check, that we could guarantee? Don't we have to do it in general? Like no matter how many times we get lucky, it's not proof, it's just evidence, right? But it's not real proof. So the real proof, we're gonna skip it here, but I think you're gonna do some of it in the activity. You guys remember from last class that in order to show that two functions are inverses, you compose them, start with x, go somewhere, come right back to x in both directions. Either you do the f first and then f inverse, or do the f inverse and then the f, right? And so normally we would do this. I said we wouldn't do it. We'll just do one direction, and then you'll practice in the activity. Let's do this guy right here. F of f inverse of x equals. Which function are we applying first? F inverse, which is the inside one, which means which letter are we copying for later? F. So f and then big parentheses. And so inside of those big parentheses, I see f inverse, so I better put something in here that is exactly equal to f inverse. What is that thing? That's this x plus 6 over 5, right? That is f inverse. Okay, and now here's the hardest part. I'm going to write f of x over here just so we have it on the screen. It was 5x minus 6, right? Yes, that was f of x. Okay, so here's the hard part. This particular function takes whatever's in the parentheses and puts it right there, right? It multiplies by 5 and then it subtracts 6. That's what we're doing down here. It's just more complicated, but it's the same process. Take what's in the parentheses, multiply it by 5, and subtract 6. So back here, this equals 5 times x plus 6 over 5, and then subtract 6. That's the hardest part right there. Okay, let's simplify here. What's the nicest thing to do next? Let's cancel the 5s. Don't distribute that 5. Could, but you're missing the point. Cancel them. That's why the 5 is in the bottom. And so we're left here with what? X plus 6 minus 6. And then the 6 is canceled, right? So we get x. Good. So we started with x, we went somewhere, and we came back to x. That's proof, right? We didn't just get lucky there. We might have gotten lucky with 3. Here we proved that we didn't get lucky. It works for any x. In theory, you should have to do the other direction too. F inverse of f of x. Okay, so the two basic ideas for today are to be able to look at a graph and decide whether or not the inverse is a function. That's the horizontal line test. And then finding the inverse function is that process right there. Okay, start on the activities on the next page. We'll walk around.